Have you ever heard of Pascal's Triangle? I'll show you how to generate Pascal's Triangle here. It starts pretty simply just with the number 1. And then, so in the first row of Pascal's Triangle there's only one number, that's the number 1. And then the rule for generating any other numbers, in the second row there'll be 2 numbers, in the third row there'll be 3, in the fourth row there'll be 4, etc. And the rule for generating each number is to look at what numbers above it to the left and to the right. So if there's nothing above it, just take that as a 0. So here, in the second row, I'd have a 1 here and a 1 here. Notice there's a 1 here because there's 1 to the left but nothing above it to the right. And then we can continue on here. It looks a little bit different here because now I've got 1 and 1 is 2. And I'll still end up with a 1 there. And as we continue on here, notice I'll get 3 here. And I'll get 3 there. And a 1. And it starts to look a little bit different here. Notice 3 and 3 here is 6. And then 4 and 1. We'll just do 1 or 2 more rows. 5. This time I've got 10, 10, 5, 1, and we'll just do one more row. 1, 1 and 5 is 6, 5 and 10, 15, 10 and 10, 20, 10 and 5, 15, 5 and 1, 6 and 1. And this is quite a symmetrical triangle of numbers. And I just want to look at some of the patterns that start to occur. So you can see if we look in sort of diagonal lines down through here, and if we look down through here, there we can see our counting numbers. As they move through there. But have a look at this next set of numbers that run through here. 1, 3, 6, 10, 15. If you'd read one of my previous posts, you might actually recognise those as the triangle numbers. And you can probably see why, because if you remember, the triangle numbers were gained from adding sequential counting numbers, so 1 and 2. Notice where that 1 is, it's there, and 1 and 2 gives me 3. And then the next counting number is 3 and 3 and 3 gives me 6. And the next counting number is 4 and 4 and 6 gives me 10. And so they pack nicely into a triangle. So there's the triangular numbers. But then we could say, well, if we add counting numbers and we get triangle numbers, what happens if we keep adding triangle numbers? I wonder what these give us.